So last class we were discussed about the speed governor system. So now we'll see the animation of how the speed governor is acting according to the incremental of load and according to the decremental of load. So you just observe here that here the portion is representing the load. So here the position of speed governor load is at working load. That means you assume that it is a optimal load, right? Now if this position is moved to rightwards, we can assume that the load is increased. If the position is moved left side, the load is decreased. Whenever load increases, the rotation speed should be decreases. Whenever the load decreases, the rotation should be, or rotation speed should be increases, right? So we'll see. And according to this working load, the wall position is placed here. Wall position is placed here. That means this much of steam flow or water flow is possible. This much of steam flow or water flow is possible. Now this is the speed changer position setting. This position is speed changer position setting. So if the load is increased, this will move downwards or upwards. If the load decreases, this will move downwards. Like that, this will be operated. As this speed changer position or speed governor is moving either upwards or downwards, the wall position will be changing according to the operation of speed governor. So we'll observe how it is happening, right? Now observe, it is rotating with respect to certain speed at working condition, that is 2000 rpm. Now the speed is increased to high load. The load demand is increased to high load. That means maximum amount of the load is applied on that particular turbine. So whenever it is moved to high load, the speed has to be increased. The speed has to be increased. So whenever the speed need to be increased, the speed changer or speed governor position has to come down. So previously the position was like this. Now it is come down. Whenever it is come down, the lever or the linkage mechanism is operating according to this movement of speed governor, and the wall is open. Wall is open. So whenever the wall opens to higher extent, the higher amount of the steam will be coming through the wall, and the higher amount of the steam will be hitting to the turbine blade, so that higher amount of the generation can be generated, so that the incremental demand can be satisfied and frequency will be maintained constant, right? Now we'll see how it is behaving whenever the demand is decreased. And see here, whenever the demand is increased, previously that was 2000 rpm, or you can say anything. Now as the incremental of demand takes place, the speed is decreased, right? And with respect to incremental steam, the speed is adjusted to increment the value. So like that it will be adjusted till we reach the rated value, that is optimal speed, that is 200 here. Now the demand is decreased to lower level. The demand is decreased to lower level. So the steam governor is, or speed governor is moved to upward direction. So whenever it is moving upward direction, the wall is closed here. The wall closed here. So the amount of input going through this wall will be reduces. So like this, the speed governor will be operating, right?